Welcome to Ask and Learn.
For the radius of convergence, we take the limit as n goes to infinity, absolute value of an over an plus 1, and we want for this to be less than 1. The an's here is this 2 to the n times n squared. Okay, so up top we're going to have 2 to the n squared. Down in the denominator we have 2 to the n plus 1 times n plus 1 squared. So 2 to the n divided by 2 to the n plus 1 is 1/2. And then n squared over n plus 1 squared is n over n plus 1 squared. Limit as n goes to infinity of n over n plus 1 is 1. So this turns into 1 squared. So 1/2 times 1 squared, so we just get 1/2. So 1/2 is the radius of convergence. So this is our r. For the interval of convergence, we need to figure out whether or not we include minus 1/2 and whether or not we include 1/2. Okay, so we need to check to see whether or not we get convergence for those values. Okay, so this was the sum that we had. We had 2 to the n times n squared times x to the n, and we were going from n equals 1 to infinity. So we wanted to check our endpoints. So we needed to check minus 1/2. So plug in minus 1/2 here and see whether or not we get convergence. So when we plug in minus 1/2 for x, we get minus 1/2 to the n. So if we rewrite that a little bit, we get minus 1 to the n times 1/2 to the n. So 2 to the n, 1/2 to the n cancel. And this should be clear that this is not going to converge because the terms do not go to 0. So that is going to diverge. And similarly, when x is 1/2, the terms that we get are going to be 2 to the n squared, 1/2 to the n. So the terms that we're going to be summing up is just n squared, which clearly do not go to 0, so we can't possibly have convergence. So that's also going to diverge. So both of the endpoints we have to toss out. So the interval of convergence, we throw out both minus 1/2 and 1/2 and just leave it as this open interval here.